there are days where you feel like a moron, and I've been going through that the last 2 days. When looking at Harrington's model of the orbit of planet X, there's two things you always have to take into consideration. One is that the model of the solar system is flipped. So that places Sagittarius up where Aries is currently. So also in Harrington's model, you have to remember the sun is, some people say it's moving 250 kilometers a second, but when you're traveling 800,000 miles an hour, you can imagine in a year how far you'll travel, but in 3,600 years, you're going to move a long, long way. So the orbit of planet X can never be identical to any previous orbit. The movement of the sun will take planet X all the way around the center of our galaxy, and which takes something like 235 million years. So you can see over a long, long period of time how through just the movement of the sun, how it would take and attract comets and its binary twin to different locations that are quite different than the previous orbit. And so Harrington's model is obsolete. Once this thing reaches perihelion and goes out of the solar system, it's on a different orbit. And so forgetting that Sagittarius and Scorpio are in a completely opposite part of the sky, forgetting that the model of Harrington's orbit is flipped, I wrongfully identified the constellation that we were looking at for planet X as Sagittarius, which it's not. Currently, Uranus is in Aries, and this object is out in front of the orbit of Uranus, which makes very, very slow progress through the sky and around the sun. And so it'll be in Aries, Uranus will be, for several years, probably another 10 years. And so we had to try to identify what constellation actually this planet X is. And we vectored our last earthquakes. We had two series of clusters, one with a 90-degree alignment with the sun and planet X, with Earth being caught in that 90-degree, which is geo-effective. And then it was the Earth-Venus planet X alignment, a very short-lived cluster of quakes that did not involve the sun. So when we vectored these out, we extended the vectors till they crossed. And they didn't cross until about the orbital of Uranus. Now, for about a year, we're saying this thing was approaching Saturn's orbital, that it was crossing Saturn's orbital. We had it estimated that it was at least half an AU past Saturn's orbital. But when we vector the last two quake series, these vectors don't cross until almost the orbit of Uranus. So then if we have a good firm vector and a nice clear-cut beginning and end to an earthquake sequence that mimics a large body alignment, then we're seeing this thing has already made it to Uranus. And Uranus is out there. It's almost 3 billion kilometers from the sun. So we take when Planet X was pretty much, passing by the sun on its way towards Uranus. That's been not quite 2 years since that's happened. It's been a little less, about 1.7 years. In 2019 we had that big magnetic shift. 2018 in December was when it crossed the ecliptic in Leo. So what we're calibrating now then is like, well, if we have a pretty good mark on its distance, we could calculate its speed, and we could calculate its speed at different points in the orbit based upon the distance that these planets and these, what I call landmarks, are away from the sun. And when doing the math, we come out with a couple different speeds. But at perihelion, we had this thing going now at 75 kilometers a second up to 125 kilometers a second. Currently, we have this thing going anywhere from 53 kilometers a second to 75 kilometers a second. And that's just using, rate times equals distance. Simple math equation using either division or multiplication, working forward, working back, it doesn't matter. And we found that this thing is approaching Uranus. Now, we were able to pretty much calculate its speed at perihelion and leaving the solar system. The problem with calculating the speed is you're getting linear speed, you're getting from point A to point B. This thing isn't just going out towards Uranus, it's also climbing northerly. So this actual speed is faster than the calculation. But we're not going to get into trigonometry and cosines and sine and cosine, and that's just a little too rough to demonstrate. But so we get a speed that's kind of close to the average speed of Halley's Comet. Halley's Comet comes out of Aquarius. Other comet groups come out of Aquarius. Some comets reach 400 kilometers a second, depending how close to the sun they get. Well, Halley's Comet gets in between Mercury and Venus, but this thing never came closer than the asteroid belt. So you're expecting its maximum speed to be slower than Halley's Comet. But meanwhile, when we vector the position, you see that we're getting a spot out by Uranus, or the orbital of Uranus. So that places it more towards and in between the constellations Taurus and Gemini, and Pleiades is in there too.